In this video, we are going to take a look at trig models. Trig models will include everything that we need to use trigonometry for in order to evaluate story problems. It's going to include right triangle models that you've dealt with in the past in your geometry course. It is also going to deal with trig equations, so writing equations, finding a cosine or sine equation, and then also just any sort of thing that you might have to use trig for in order to evaluate. So we're going to start with the following right triangle trig problem. So a hiker is 300 meters from the base of a radio tower. The angle of elevation to the top of the tower is 40 degrees. How tall is the tower? So on a right triangle trig model, you're going to need to draw your picture. So I've got this radio tower here. I have a person standing outside. The angle of elevation to the top of the tower, which means this angle. Remember, elevation goes from the horizon up for elevation or from the horizon down. So elevation, horizon up, that angle is 40 degrees. And the hiker is 300 meters away from its base. I want to figure out how tall my tower is. So now I have to look at, okay, what information do I have based on my angle? I've got an opposite side, I've got an adjacent side, so I'm going to have to use which trig function? So the tangent of my angle equals opposite over adjacent. Please keep in mind I'm dealing with degree measurements. I'm going to hit that tangent button in my calculator, so I've got to make sure that my mode is in the right mode. Whenever you hit that sine, cosine, or tangent button, make sure your mode is appropriate. So if it's not in degrees, change it into degrees. I've got to get x by itself, isolating x. X is in my numerator, which is where I need it to be. Therefore, get rid of your 300. That is divided by multiplying. So I take the tangent of 40, multiply by 300. And x equals 251.73 meters. So that's how tall your radio tower is. Okay, so going through this process, setting up your trig function. So very straightforward as that. Sometimes maybe I'll have the x in the denominator. That's about as hard as they get. It is important, though, that your picture is drawn appropriately. Okay? Angle of elevation versus angle of depression, making sure that you get that correct measurement in there. So those are the ones that you've had practice with. You'll have some practice problems on that. The second type that I'm going to go through in this lecture deals with writing your equation based off of information. So here's my information. I need to write an equation, and I asked you to write a cosine equation for this. So if I'm going to write my cosine equation, I'm going to need to find my A, B, C, and D values in order to plug all of this information in. So now we have to think about how did I find all of that information for writing equations from the previous section when we practiced just writing them. So to begin with, my recommendation according to this problem is to make a scatter plot of your data. By making a scatter plot, it gives you a nice visual representation of what falls where. It's going to help you hopefully kind of distinguish between where is my maximums, where's my minimums, where's my midline, what's my period. All of that stuff comes into play. My horizontal shift, my vertical shift, again based on that midline. But you can visually see where this stuff comes into play. So to begin with, I'm going to make a scatter plot. So when I make my scatter plot, I've got to look at my x-axis is going to be the number of days greater than or equal to. So I'm going to start at 0. So this is 0 days. Let's see, let's count by maybe 50s. So this is the days of the year. And then my y value is my temperature in degrees Fahrenheit. So I'm going to have to figure out what I need to count my y-axis by. You may wish to jump because it looks like it goes from 30 up, but just as easy, it might be just to count by 10s straight up. So there's the basics to my graph. Now I'm going to have to put my points on because I'm going to make a scatter plot. So I'm just going to randomly plot each of these points along the way, keeping in mind by no means are these perfect. Again, please keep in mind these are not perfect by any means, and these are actually representative of this specific case. So if you notice, this is a nice trig function. There's a nice curve up, and it curves back down. So if I were to connect those dots, I could then keep going after day 350, go out to 365, which is really kind of back to day 0. And I can keep going with this pattern. It's going to definitely continue to repeat. So now I have to figure out all of my information. So this kind of represents, yes, this is a trig picture. So I have to figure out my A, B, C, and D. I'm going to start with my period. When does this repeat itself? What is from start to finish? 365 days, because this is in days. So my period is 365 days. So you know that 2 pi over b equals your period. Or b equals 2 pi over 365. There's b. Done. That's the one value I have to have as my b value. Okay, so I go through here, and I just found my b. Now I have to find where my midline is going to be. That midline is going to deal with how far up and down it's shifting. So that's your d value, which then also controls your a value. So if I want to find my vertical pieces, I'm going to have to find where that midline is. In order to find my midline, I have to find my max value and my min value, because that midline has to fall halfway between there. So I look at my data. Now I can visually see approximately maybe that this looks like my max and this looks like my min. Now I'm going to look in my table to calculate that better. So when I look for those up and down values, are those x's or y's? Those are my y values. So I've got to figure out what's my max temperature, what's my min temperature. So it looks like on here my max temperature is 77, and it looks like my min temperature is 33. So it gives me my max value, it gives me my min value. So halfway between there is going to be my midline. So to find my d value, to find that midline, figure out approximately where it falls in between, looks like maybe about there is my midline, I've got to find halfway between, which is called our average. So 77 plus 33, and average that, divide it by 2. Okay. Gives me my midline to be 55. So crosses maybe here, just a smidge. So there's my midline. I just found D. So that's how far up it moved off of my x-axis. So therefore, I should be able to find my A value, my amplitude, by finding the distance between your midline and your max value, or between your midline and your min value. So my max was at 77. I just found out that my midline's at 55. Therefore, my A value is just your max minus your midline, or your midline minus your min. Either way you want to do it is fine. So therefore, I end up getting A is 22. I now have A. All I have to do lastly is find C. Now think about what C is. It's attached to your x value. It's that horizontal shift. Think about what function I'm using. I'm using a cosine function, so that starting point has to be located at its maximum. So how far over does your maximum shift? That is probably one of the most straightforward parts once you find where your maximum is. My maximum, y value, is at 77. Therefore, this max point is shifted over 198 days. So to write my cosine equation, I have to shift over 198 days. Again, because it's cosine. So I have A, I have B, I now have C, and I had D. So now I can write my equation. So y equals my A value, which is 22, times the cosine of my B value, which is 2 pi over 365. Kind of weird, but that's how we write it. Because it's in radian mode, x minus my C plus my D. So now I can plug in any day I want for x over the course of this calendar, and it will give me the temperature, or approximately what it should be equal to. Now keep in mind, if I wanted to write my sine equation, if I want to do sine, then I must find this point here, how far over it travels. Because remember, sine is on that midline, that upswing part of the midline, unless you have a negative multiplier. So if it's on the upside of my midline, I've got to find my min value, which was 16, and my max value, and find halfway between. That should be where it approximately crosses at your midline piece. Because again, it's a horizontal shift. So the only thing that would affect my change if it was a sine is the minus part. And it's minus because it's shifting it to the right. This is where the majority of your models should be focused at. This is the new stuff that you might need a little extra practice with. I highly recommend drawing that dot plot so that you can kind of see where it's at, calculating them, and not only finding your cosine equation, but sometimes finding your sine as well, just to make sure that you're able to find both equations.